Hello students, welcome to Physics Bouquet. In today's video, we will discuss the remaining part of the dielectric sphere placed in a uniform electric field. And in previous video, we had derived the expression for potential outside the dielectric sphere and inside the dielectric sphere. Today we will derive the expression for electric field outside and electric field inside, and for that we have to take the help of potential derived potential outside the sphere and potential inside the sphere. These two we have already derived in previous video. So electric field expression for electric field. पहले outside the sphere, electric field outside the sphere. Let me write ER2 outside. Then we know that it is equal to the potential gradient. And we will consider, since it is outside the sphere, therefore we will consider the potential outside the sphere. Alright? Now find out the differentiation of VO with respect to R. See, already there is a minus plus. This after taking differentiation, this R will be no more there. So we will get, for the first term we will get E0 cos theta. This minus this becomes plus. Then for the second term, this minus and plus minus, and this is constant k minus 1 into by k plus 2 E0 AQ cos theta. Then derivative of 1 by r square, it is minus 2 by r. Hence we have ER outside is equal to E0 cos theta. This minus and minus become plus. There will be 2 will be multiplied here. So k minus 1 by k plus 2 E0 AQ by RQ cos theta. So this is the expression for ER, electric field outside the dielectric sphere. So two parts here. Perhaps it was equation number 5 and equation number 6 as I recall. Let it be equation number 7. We will find out electric field for theta component, E theta outside. This is ER outside, this is E theta outside. For E theta, we have minus 1 by r. Since it is outside, this del VO by del theta. Or we can write E theta outside is equal to minus 1 by r इसका डेरिवेटिव विथ रेस्पेक्ट टू थीटा. So there is minus E0 r cos थीटा का डेरिवेटिव माइनस साइन थीटा. तो पहला टर्म का डेरिवेटिव हो गया. फिर सेकेंड टर्म लॉस k माइनस 1 बाई k प्लस 2 E0 a क्यूब बाय आर स्क्वायर और प्लस थीटा का डेरिवेटिव माइनस साइन थीटा. और we have e theta outside is equal to, open the bracket, this minus minus plus and again this minus, so it becomes minus, this r and r cancel out, we get minus E0 sin theta. Then this minus plus this minus and here is minus before sin theta, so it becomes plus k minus 1 by k plus 2 E0 a cube by r square sin theta. और e theta outside is equal to, we can take common minus 0, we can put sin theta also outside, so 1 minus k minus 1 by k plus 2 E0 a cube by r. E0 is outside, so no E0, a cube by r square sin theta. One more thing, here also we can take common E0 and get the expression ER outside is equal to, take common E0 and also take common cos theta. So here 1 plus k minus 1 by k plus 2 2 a cube by r cube. This is, let it be equation 7. Instead of making it 7, let it be 7 and let this be 8. So we obtain electric field for outside for this polar axis component and theta component. So we get ER as well as E theta outside the dielectric sphere. Now let us derive now for inside. Inside the sphere, here we will write ER. For inside, let me write I. Then it is potential gradient of and since it is inside, we will take this expression, or ER I is equal to, this minus minus become plus, so 3 is 0 by k plus 2. After differentiation there will be no r, so this will be ERI is equal to 3 is 0 by k plus 2 cos theta. Let it be equation number 9. And E theta I it will be minus 1 by r del Vi by del t, or we obtain E theta I is equal to minus 1 by r del Vi by del theta. We will differentiate it with respect to theta. So minus 3 by k plus 2 r cos theta का derivative minus sin theta. Hence we have E theta I is equal to this r cancel out, minus minus plus, so 3 by k plus 2 sin theta. Of course there is another minus, so this minus minus minus, so it will be minus this much. Let it be equation number 10. In this way, we obtain the expressions for electric field outside the sphere and inside the sphere. Little more discussion is there, so have patience. It was k minus 1 to aq by rq cos theta. Field inside the sphere, we have little bit more discussions, more analysis is there. You see, ER inside is this much and E theta inside is this much. So resultant electric field inside the sphere, resultant electric field inside the sphere is ER inside square plus E theta inside the square, R component theta. So root over of इसका स्क्वायर मतलब 3 by k plus 2 का स्क्वायर थीटा, and that is minus minus का स्क्वायर again plus हो जाएगा. So 3 by k plus 2, दोनों में हम कॉमन ले सकते हैं. It is 3 by k plus 2 whole square or square theta plus 3 by k plus 2 whole square sin square theta. Correct? If we take common these two, 3 by k plus 2 whole square, if taken common, within the bracket there will be cos square theta plus sin square theta, but cos square theta plus sin square theta is 1, और तो रूट ओवर के नीचे क्या रहेगा 3 by k plus 2 whole square, और as a result it will be 3 by k plus 2. So resultant electric field inside the sphere is EI is equal to 3 by k plus 2. Right? One more thing I want to tell. You see, it is 3 by k plus 2. If k is 1, if k is 1, then it will be 1 plus 2 3, 3 cancel. Then we have resultant electric field inside is equal to applied electric field, uniform electric field applied. This is one condition. Second condition, for a conductor conductor. What is the value of K? K is infinity. Dielectric constant is infinite. So what will be EI? 3 is 0 by infinity, and this is 0. So for a conducting sphere, electric field inside is 0. There is no electric field inside the sphere, inside a conducting sphere. Then third one, our K is, if K is greater than 1, K is never less than 1. Either it is equal to 1 or greater than 1. If K is greater than 1, then this EI will be less than 0. EI 3 by I is less than 0. So these are three things to be discussed, and then I will derive an expression for polarization P. So again I have to go to the expression for potential outside. Potential outside is minus E0 R cos theta plus K minus 1 by K plus 2 E0 AQ by R square cos theta. You see, here it contains two terms. This is original potential minus E0 R cos theta. But this extra term, it arises due to polarized charges, and if it is called dipole moment factor. As in conducting sphere we had discussed, this second term K minus 1 by K plus 2 E0 AQ by R square cos theta. Equate it with the general expression for potential due to a dipole. This is potential due expression for potential due to a dipole at any point. At any point in terms of polar coordinates r and theta. So if we equate these two, you see these are cancelled, then we get dipole moment is equal to 4 pi epsilon naught K minus 1 by K plus 2 E0 AQ. So this is dipole moment. So this much dipole moment develops in the dielectric sphere. That means dielectric sphere acts as a dipole when placed in an electric field, and its dipole moment is equal to this much. So this potential outside the dielectric sphere is combination of two terms. One is its original potential and another is potential due to its dipole moment, and the dipole moment of the dielectric sphere is given by this much. From this dipole moment we can find out the polarization, and from the definition of polarization polarization is equal to dipole moment per unit volume 4 by 3 pi aq. This is the volume of the dielectric sphere. Volume of this ये sphere का volume का formula. So polarization is equal to dipole moment by this much. But polarization कितना है? ये है. So P is 4 pi epsilon naught k minus 1 by k plus 2 E0 aq divided by 4 by 3 pi aq. 4 cancel, pi cancel, aq cancel. So polarization is equal to, we obtain this 3 will go up. So 3 epsilon 0 k minus 1 by k plus 2 into E0. So this is the expression for polarization. This is equation number perhaps 10 or 11. ये 11 है, EI 11. Let us make it 12. EI हमने निकाले हैं. EI is equal to 3 E0 by K plus 2. इसको थोड़ा इक्वेशन 11 को रखें. इसको मैं लिख सकता हूँ K plus 2 minus k minus 1 E0 by k plus 2. Right? It is 3. 3 के जगह मैंने लिख दिया k plus 2 minus k minus 1. So k minus k cancel. So 2 minus minus plus 2 plus 1. So 3. It can be written as k plus 2 divided by k plus 2 1. So 1 minus k minus 1 by k plus 2 is 0. Or this is E0 minus k minus 1 by k plus 2 is 0. Now refer to equation number 12. Equation number 12 में you see k minus 1 into k by k plus 2 into is 0. Here also k minus 1 by k plus 2 is 0. This is equal to p by 3 is 0. Sorry, p by 3 epsilon naught. P is polarization. Polarization by 3 epsilon naught. So इसके जगह मैं लिख सकता हूँ. So EI is equal to E0 minus P by 3 epsilon naught. So electric field inside the sphere can be expressed. Sometimes it is asked to derive Clausius-Moissault formula. Clausius-Moissault formula क्या है? हमारा जो पोलराइजेशन होता है, ये पोलराइजेशन ये it is directly proportional to zero, and this polarization is equal to alpha n is 0. अल्फा क्या है? मॉलिक्यूलर पोलराइजेबिलिटी. मॉलिक्यूलर polarizability, and this is number of molecules per unit volume. n is क्या? Number of molecules per unit volume. Let it be equation 13. Now equation 12. So P is equal to alpha n is 0, and here in equation 12 we have obtained P is equal to 3 epsilon naught k minus 1 by k plus 2 is 0. If we compare equation number 13 and 12, we get alpha n is 0 is equal to 3 epsilon naught k minus 1 by k plus 2 into E0, where alpha is molecular polarizability and n is number of molecules per unit volume. So both sides E0 cancel out. So after cancellation of E0, we get alpha is equal to 3 epsilon naught divided by n into k minus 1 by k plus 2. This formula is popularly known as Clausius-Moissault formula. This completes the dielectric sphere in a uniform electric field. नेक्स्ट वीडियो में हम एक न्यू टॉपिक के साथ मिलेंगे. हैव ए गुड डे.